Okay. Welcome everybody. It's a real pleasure to have Riccardo Di Clemente here with us today for our penultimate colloquium of the year. And Riccardo is currently an associate professor at Northeastern University, but in their London campus. And he's an affiliated researcher at the ISI Foundation. He began his career as a complex systems researcher in Italy, focusing on the application of network theory and economic systems. Later, he worked as a researcher at MIT and UCL, studying human interaction from credit card and mobile phone data. Riccardo has been awarded the Newton International Fellowship of the Royal Society and the Alan Turing Fellowship for his research on developing data analytic tools for understanding urban dynamics. And he's now in the Complex Connections Lab. Riccardo and his team are using applied network theory, computational social science, and machine learning on the digital footprints to gain insights into city social mixing and urban segregation dynamics. So without further ado, the floor and the screen are yours, Riccardo.
Thank you so much. Thank you so much. Let me finish and then we'll see if I deserve applause. So I should have given you an introduction on myself, but then it was done very, very good. So just summarizing, basically, I started my career as a physicist. Then I had a little PhD in economics, but basically studied complex system applied to economics and social dynamics. Then I moved. Then I moved to basically to MIT when I started to fall in love to city and urban dynamics. I was a postdoc under Marta Gonzalez. Then after 2 years, I need to come back to Europe because I missed my country, my continent. And so I was able to go to UCL for 2 years, and then I became professor lecturer in data science at Exeter. And now I'm here at Northeastern. So as already has been introduced, my lab works basically on urban dynamics, use the digital fingerprint that you can collect for different tests. The light. So the digital fingerprint that you can collect from mobile phones or credit cards in order to understand better how people interact in the city. And then we have a little part of my lab that works either in social dynamics, in social networks, but we try to use the similar tools that basically we implemented, we developed in city science to social dynamics. So we will not talk about the second stuff, we'll talk a little bit more about the first one. So what my lab is interested in is recently in the time-space dynamic in cities. So as you know, cities are a physical space, but then we move inside the cities, we interact within each other, and when we interact and where we go to interact, so when and where, changes our perception of the cities, it changes our either possibility to have to basically reach other opportunities. So this is important in terms of the social mixing, so where the social mixing happened, how it happened, and if it changed during the times of the day, depending on the area where you're physically are in the city. Then something relates, and we will see in the paper that we will show, to the differences about basically step up the simple understanding of our residential segregation in cities, but either try to understand the segregation that we, or at least what we perceive, and the people that we interact within our journey to all the physical area that we touch in cities. And then, of course, in doing that, we have to study a little bit of mobility and how we interact with it. So the idea of this talk is providing 3 different papers. There are 3 different stages of their life. One has been published, accepted. It's going to be the second one. The first one is being under review, and it's going to be under review again soon. And the third one, we are working on it, almost finished. The PhD students, we are almost there. They have to finish their PhD, so probably will be done soon. Both of these 3 papers use mobile phone data on cities, but at 3 different levels. The first paper will use basically all the information that we can retrieve from mobile phone. The second paper will start to use less information, so more aggregated. And the third one will be the higher aggregated level. So the idea is that to give you how we can achieve, how we can understand city with the same data, but 3 different levels, because since we are talking about Europe, privacy is very important. GDPR is very important. And so I would like to give you either a glimpse of how we can use this data with different aggregation levels, either to achieve, I think, feasible or good result. Okay. So starting for that, the first paper is Lavinia, main paper from her PhD dissertation, and is the detailed space dynamics of income segregation, a case of study from the city of Milan. So here we are connecting to the first part, so the first point of the introduction of the tool. So we know that we live in cities. Cities are incredible point of interest, point of aggregation of people, but there is a huge problem in cities that is, of course, segregation. There are different aspects in segregation. There can be gender segregation, there can be religion segregation, belief segregation in this case, or it can be either income segregation. This is a map from London, income based, and as you can see, it's very easy. If you have a look about the residential segregation of the city, you see there are different patches of different color. So these are relative, very easy straightforward approach about census, and you can do this map with every cities that you have data from. So then we know that the segregation has a cost, has an inherent cost, because basically injures the economic growth of the cities, injures the possibility to interact with each other and to improve. And so has like several problems. One is like slowing the economic growth, then provides less innovation, because basically if you're not able to reach opportunities to be in contact with all the people and different people, then ideas doesn't spur and doesn't create. So there is less innovation, is less resilient, because accessibility matters. And then if you cannot access to healthcare, there is less healthcare in your area, and so on and so forth. And then of course, higher criminality. Of course, in overall, if you live in a segregated area, then you have less possibility to access to higher education. There's been statistics that show us that there is a shorter lifespan. And then, of course, there is less opportunity for you to move across the ladder of the economic, and so to improve your upper mobility. So there are a couple of papers by Chetty in the recent year, in the last 2 years in Nature. They basically try to envision this idea about economic connectedness. So basically that communities that are rich and are the ones that are able to bridge social capital. So we need communities and we need cities that are more inclusive, and so they are able to connect and to interconnect people from different backgrounds. In this case, not only about, of course, background that can be religious, can be cultural background, education background, but either at economic level. So there are different approaches that start to study how people interact within the cities and using mobile phone data. One is just taking in consideration all the movement that you do in the cities, how you, in this kind of movement, in this trajectory, then you're able to connect with other people. Then, of course, we are able to assess with the land user if an area is residential area, if it's commercial areas, and then maybe using census data, we cross-check this information in order to understand who is going to be the person that basically is going to live there, having interaction in that particular area of the city. Recently, there is an approach by Esteban model that basically starts to using mobile phone data in order to track your activity and where you go to the shops, to different shops, and then you are able to provide basically a proxy of a distribution for each of these shops. There are people from different income are basically going there. And of course, there are all the analysis that one can do in the experience segregation, either the quality of the store. These approaches has been done at like stores level, and then can give you either a wide idea about with the color, which are the area that is more or less segregated by income. So we will try to move a little bit further, to advance a little bit this approach and try to study neighborhood and how we interact in neighborhood. But then in the previous approach, all this information, for example, the model one, was based about the distribution along all the day. So our idea is like study the neighborhood, how they change the segregation experience through all the day. In doing so, we start from mobile phone data. I don't know how many of you are aware about mobile phone data. There is this new generation that is location-based data. There is basically data that once you collect from the app, give you spins through the day, depending on the app that you use. So there is some bias depending on the app that you use, depending on the provider that you have, etc., etc. But you can basically create or at least data sanitize this bias and say that they can provide you a good feeling about the population, the entire population of the city, depending on the city, of course. But then we have our points. Then there are algorithms that you can implement in order to get stops. So when you stop in particular, meaning that probably you stay for more than 10 minutes, not far than 50 meters or 10 meters, depending on the accuracy, but just to give you an idea, okay? 13 meters, but this is it's okay? Yes. So then once you have the stops, of course, you are able to detect what? Home, work, and all the other locations that you do throughout the day. So basically, you are able to build the travel diaries of each person. So we have, for the city of Milan, 8 months of data, 25 million of stops, around 100,000 users before the cleaning. Then some cleanings. We are around this is the correct one. Already cleaned, sorry. We start from 2 million. Okay. Then
What's the fraction of the population, more or less?
the urban like metropolitan area, we are around 4 million. Literally one of the 4 people on this system. And then every time you remove all the people that go around for like crazy. So they're the one that are too many apps. Despite the one that are too few apps. So you do some cleaning and 110, and then you arrive to this basically. So first thing is just the data are anonymous. We have no information about the person, if it's men or women, if like, age, any information. So we have to recover this information. The one that we are interested in is income. So how we do that, there is a lot of approaches that go through this, how we are able to assign income. One of the most common can be census data, but in Italy, census data has not a high granularity level at income level. So we came up with the idea about using the rent. We're able to download all the information about the rents and the housing, basically. And then we see that this rent correlates with the distribution of income inside the city. Of course, there is some error, but we are within a good percentile. And then basically we are able to assign to all our users a proxy that basically represent their presumable income level. Okay? Then we collect all the information from the point of interest of the city of Milan. There are 400,000 locations using Google. So then these are divided by stores, coffee, health, trans, everything. Up to that, we collect information about their reviewing. They're good, bad, so-so, not so very good. And then either the cost. Okay, but the cost is always about how they be perceived by the people that do the review. So $1, $2, etc. So then with all this information, we want to characterize the neighborhood. Okay, we create this clusterization that basically gives an idea of aggregates neighborhood by similarities in their attributes. And our clusterization is named as ALA because it's like accessibility. So how it's easy to move to reach a given public transportation. So how fast you can move from the city. Livability that represents basically how it diverse your neighborhood in terms about the type of POI, income means is expensive this POI or not, the level of the POI. And finally, the attractivity. So it means that if you have unique point of interest, or if you have like a very diverse neighborhood with very strange, very diverse prices, etc. And so for the reason we label ALA clustering. So here you can see that the distribution of all the metrics that we take in consideration, so the rating, the values of the buildings, in this case was the rent, then we have the prices about the POI, the category diversity, the supermarket, we divide the supermarket in two, so basically we have the supermarket and then either the diversity in supermarket, because you know there are different levels of supermarket for like more wealthy people and less wealthy people. And then we track the velocity score and the fitness is a matrix that come from economic complexity that basically represent a sort of diversification, ranked diversification of the city. So done that, we clusterize this using k-means. And the neighborhood for us is hexagons. We did all the cross-check about hexagon south, translation of the hexagon, and more or less the results are coherent. So as you can see from Milan here, okay, here, you can see there is a radial pattern that is very typical from all the Italian cities. Very old one, they start with like a chunk of city that's been built 2000 years ago, and then sprawl around. And so, but then very interesting, each of these cluster has a very peculiar fingerprint that you can see here. The red line is the median, and the three colors represent the three different fingerprints. So we have three clusters that describe basically these three areas. So then,
Can I ask a question?
yeah, sure.
So it's interesting you don't seem to have rich suburbs or suburbs that would have the be yellow by your classification. Is that right? Am I interpreting that right?
Yeah.
Seems like all the desirable places
So
and so on. are in the
basically,
same-
the area that we cut is basically the high dense metropolitan area and a little bit more. And then we are not arriving to the first neighborhood of little villages that basically now are integrated with Milan. They are the richer one.
Mhm.
So we are really cutting in. So this was actually one of a reply of a reviewer. And because of course there is the border problems. And but this border problem basically we can say that we have data only for the city. So it's like there's gonna be always some problems. So then we are interested in social mixing. So we discussed that segregation was being always analyzed a long time ago only as a static review. So the idea is like to introduce a new matrix or some new framework that can give you a sense through the spaces, through the time. So we started first just simply analyzing the Gini, this very straightforward index that provides basically how is the shapes of distribution of the income. And here you can see that the Gini actually is very interesting because we have a high Gini in the center, high Gini on the border, and something middle low in between in the ring. Okay, but then this is only two-dimensional. Let's give you information about how the distribution is, but doesn't give you an idea about is diverse to the middle, it diverse to the poor level. So we implemented this. This is like in the main paper is just a triangle, but then you can do like as many quantile as you want, as many dimensions as you want. But just to give you an idea, so if you take the distribution of your income and then you divide in quantile, that can be in this case 3, so medium, high, and low, then you can create basically a coordinate system that provides that each point is one of basically the citizen, depending how they belong in more in the low income, medium income, and high income level. And then you can study basically how each of these hexagon can be represented in this tree. So basically, if you have an hexagon with all the population that in one particular area, in this case, for example, low, you have a high segregated income at low level. Then you have a mixed, in this case, a mixed here, that is between the medium and the low. And of course, if you live in an incredible dreamy city, everything is in the center of a triangle.
Can I just have a question about the data? Like,
Yes.
So as I understand it, in order to infer and compute somebody's income, you're basically using their rent.
The medium of the first 5 houses rent nearby what we think is the home location.
So that's how you identify an individual's
Income.
income. And then you're talking about the interaction of people with different incomes in different neighborhoods.
Yeah.
And that interaction is effectively, if people lived on the same block, they would have the same improvement. So what we're really talking about is the interaction of people who come from different areas of this.
Exactly. So for the reason that will come the time, and in 3 seconds, I will show the time. So basically, we will see the difference, how the hexagons in the neighborhood change. If you're talking about night, so there are people they say that this is sleep there, and they are being given the income in that area, or the people that they move around the cities.
I have a question.
Yes.
So what's the home ownership rate? That's the only thing that's throwing me off because we're
And the
just
home,
looking at
the home
renters.
ownership rate in Milan, I think, is around 60%. Not in the center, but like in the ring that you saw going out. Yes, in Italy, we love a home owner owned the house.
Okay, so I'll just let you play out and then I'll ask my question.
Okay. So then, if you imagine this triangle and you check this triangle through all the different time frame. So in this case, we have 3 time frame. We have morning, work, sorry, this place, meaning after works, during the time that we consider in Italy, time that you go out, go to shop, eat out. And then you have the night, so basically when you sleep, okay? So the night will be our cross-check with the residential segregation by night, by income for people that actually lives in that area, okay? The work, meaning that we can able to study how these people interact during the work time, and then the third place. Of course, the results that you see here are aggregated by the cluster that we saw spatially that we created using all the information about the topology of the city depending on the point of interest. So the purple one was the low attractivity cluster. Then we have the green one that was the medium, and then we have the yellow one that was the high level about the center of the city. And what we notice is that from residential segregation, so basically for people that actually sleep in that area, the people that are actually, this is like our cross-check a posteriori for our analysis. So people with high income are the one that actually lives in the center of the city, and is well known from census data too. That was the yellow dot. Then people medium are the one that lives in the medium ring of the city, but are the one that are like low medium income. And then we have the super low income that actually lives in the suburb of the region. And then what you can see that in fixing this cluster, you can see that during the working area, there is some social mixing happening because you can track the population that interact. Okay, it's not true that interact physically, but actually they are in the same area, okay? You cannot see that if they spoke with each other, but hopefully if you work in the same area, etc., it's possible. And then you can see that they start to become some social mixing, and some social mixing happened on the edge on this triangle, and in the center, in particular, for the high cluster of the POI topology. And finally, in the third place, so when actually there is the social mixing of people that actually interact, going to restaurants, going to pubs, living their life outside in cities, in piazzas, etc., is the one that actually describe our interaction. But interestingly, we have different interaction because yes, they are going to the center of this triangle, but depending on the type of POI distribution and topology of the city in that respect, we have different cross-mixing. Then what we did is just we plot the segregation that we see before as a Gini index, changing on the time of the 3 different blocks, clusters that are describing before, like as a POI. And what we notice, of course, that we have higher segregation overall in the yellow cluster, low segregation in the purple cluster. The last step of this analysis was start to study the clusterization no more at POI level, but cluster the people they interact during time. So we want to cluster basically how change the Gini index through the time in each of these hexagons. So we take an hexagon and we plot the changes of the Gini index through the time. And then we cluster these changes. And then we got, luckily, again, cross-check, again, everything by 3, 2, 4, all the checks that you have. We got 3 clusters. So we have the cluster that has higher mixing, the cluster with medium mixing, and the cluster with low mixing. But then we have 2 topology of clusters. One is totally spatial, that provided information about segregation, and the other was only temporal. So what we can do, we can cross-check this, so see which one is in which one. And what we see is that basically, if you have a low topology, POI accessibility score, then you live more likely in the temporal segregated neighborhood. Then the mixed, of course, take all, medium, high, and low cluster. And then, of course, VI is going more in the more inclusive and the more mixed. So basically, we are providing some information about how people moves between these three rings in the city of Milan, temporally and spatially, and how they perceive their segregation.
Can you comment on, it seems like a lot of the mixing might come through the medium group. Instead of having a lot of interactions between the high and the low, it tends to be that the medium mixes with everybody, whereas the other ones less so. Is that true, or am I interpreting wrong?
No, it seems, yes, but this is a spatial one.
Right, but it's by the scores.
So, yeah, but it seems basically that all the people go to the medium ring of the cities. This is more attractive in this case. Because the city center basically has a lot of work. There are very wealthy people that live there. I never lived to Milan, so I should not talk about that, but like this is what this is, okay? So the inclusive and mixed, but where are these clusters? So we can plot this because in the plot before I show you that we have the other clustering, we have the segregation. And so now we can start study the temporal layer underneath. And what we can see is like the mixed neighborhood, actually as Louis outlined, are in this here, in the outstream of, no, like in the middle stream of a circle, but then there are some of them that are actually in the city center. And usually that one, but just for cross-check, like it's not written in the paper, I can tell you, but don't quote on that. I think are related to the pubs and to all the night activity. There are people that basically want to go to the city center to enjoy themselves during the life and then in the third, yes, during the night. And then finally, what we did is just make some cross-checking, depending all the variables that we take in consideration, how this is very important to our classification. So one thing that we cross-check is about the density of the city, because we have to be sure that basically we are not having any bias because one area is more dense in terms of residential and one is less dense. So actually we can see that density doesn't have an impact. Very interesting is like the architectural heritage is very loosey definition, but the idea is like is the piazza, Italian piazza, you know, where there are monuments, where people interact with each other. So it's been labeled in this very weird name, but like this is the idea, and it's very important. And then of course price is important. And then we have the metrics that is the fitness that basically represent, as I told you, a sort of importance of diversity of POI in the area. So this was the first paper that, if you want, is on archive, and basically give you an idea about using high granularity data, what we can achieve in understanding how you move in the space-time, how this segregation has been impacted. The second level, we have a paper from Clodomir. This has been published, and we were during the COVID time. Just checking the time. So during the COVID time, and then we want to understand basically how this time-space dimension of human mobility has been impacted due to COVID. So I don't want to remind you what happened 2 years ago, but everybody knows. So let's go a little bit ahead. And so the data that we use is always data from mobile phone data. We have the similar data that we discussed before, but we will use with a higher granularity. And stay with me a couple of minutes and we arrive there. Then we couple the information with these three data sets from the census at local authority level in UK. Local authority level are something 10,000 people, something like this. Okay, size-wise. So we have GDPR component information, of course. The dataset starts from January 2019 up to March 2021, because then we submit the paper, and was after the third wave of spatial blocking has to go around. Okay. We have 17 billion trips from 1 billion users, and then what we're gonna use, we're gonna use only two metrics from all this information. So as you know, when we move in the city, there are different things that we can take in consideration. Depends on what we do. So we go out, we go to work, we go to study, we stay at home, basically because it's night. One of the most important metrics that we use in all the literature, at least in my field, is the radius of gyration. This represents basically your whereabouts in the cities. So I don't know if you're aware about what is the radius of gyration. Basically, you take all the points that you spend across the city, and then basically you calculate the density map of and then the standard deviation of these points. And the standard deviation more or less is the radius of gyration. So it's the quantity of your whereabouts. Okay. Interesting enough, this is the formula, is that to calculate the radius of gyration, you don't need any information about house, time, work, anything. You just need a list of points of a person. And actually, you cannot, not having the list of points, you can just ask to the provider, please calculate this and give me a number for a person. But I can either ask to the provider, give me just the distribution of numbers in that particular area that people lives in that area. So this is it's not super aggregated level, but it's already, we are losing a lot of information that we don't care about the people. We just care about the people that live in that particular area. And so we're going to collect just radius of gyration. Then the second important step is that we move, as we already told you, we move in the time. So one important step that's been studied in many different fields is like the synchronicity of our movement and the synchronicity of our commuting. So when you go out from to go home and when you come back. We leave this mobility synchronicity and basically give you the idea about, okay, I'm going out at 8, I'm coming back at home at 3 because I'm a student, I don't work until 7 this night, or maybe I come back home at 8. Okay, so we need a quantity in order to assess this synchronicity. This is a physics approach. I don't want to bore you with all the mathematical approach. There is a formula that is named the Fourier transform. That basically can you study basically the synchronicity of the pattern of the wave. So then you can study how synchronous are your movement in the 24-hour span. And so you can calculate this in 12 hours, 8 hours, 6 hours, and we give you a quantity that represents basically how synchronous are your movement within 6 hours, 8 hours. So we have two simple metrics. Either this one, so very suggestion we discussed this one for privacy level. So when we ask to the provider, just okay, geofence our users in a space about 500 meters. Every time they step out, you give us a time step. When they step in, they re-enter, you give a time step. So we don't care about who are the people, how many times they are going in and out. You just collection, step in, step out, and of a global area that we are discussing, the local authorities. So we don't track the person, we don't track anything. Step in, step out. We run this with the Fourier transform, and then we have a number. So for each of these local authorities, we have two numbers that change during the different days, time and space. So let's have a look about this. So we take the 2019, because we have all the year as a baseline. We will have always the space in red and always the time in blue. And as you can see, it's like that, given the baseline, after the first lockdown, space and time go down. So lose of time, lose of space. Then these come back. First is the space that's coming back. Any idea why? I had to answer to this question to the referee, so it's going to be in the last figure of the paper. But do you have any idea why? How you experience your COVID, and then what happened after between slowed down? You stay at home all the time.
No,
No, you work. Sometimes you work around, you go to shop, maybe to supermarket, whatever. So the space is coming back in a different way, but it's coming back. But then you do all these activities not synchronously, because everybody of you is like going out at different time and you're not going as a normal routine of working. And so we see that the time is lagging behind. Then it's very interesting because in the second lockdown, the third lockdown, we have a switch of a time and space. And we start to study this in the next slide. So the first thing that came in our mind was like try to disentangle this by urban area. So this definition comes from a census. It's not up to me. I didn't do that. Just like there is like some metrics that give you, this is a rural area in the UK, this is an urban area, this is mixed area, okay? So you see, this is the story. And then what we did, we studied the changes for space and time if they were if you live in the urban or in the rural area. And what we notice is that the space doesn't change too much. The time, yes. Any guesses? So, okay, the guesses for me is like, I don't know, because remember, I'm in this data, we are losing the privacy, keeping the privacy as much as possible, so we don't have any information. I can give you some just guesses on that. But in rural area, what we have people that actually bought us food, and the routine of farmers are always the same, and they need to be the same, either under COVID restriction. And so the time, in that case, is impacted. So they have to wake up when the sun rises because they have the stuff to do, okay? So the time, there is still some activity in the time that is regulated, and we were able to capture this activity using the Fourier transform. Of course, we are not seeing this over the space, because imagine that if you have a benchmark that basically check your whereabouts, but then your whereabouts are linked to what you do during the day, and you're still doing the same stuff during COVID, what you are checking here is the delta, that basically is the activity outside of what they actually do, okay? But remember, this was not in the paper, it's our assumption for how to describe it. Okay. Then the second check that we did studying the unemployment level. So we studied the unemployment level depending on urbanization before and during COVID, and the same for the time and the space. What we notice is, of course, we have a steep drop on unemployment level, of course, but the time is the one that is more affected, respected the space. And it's reasonable, because if you are checking unemployment, if you're unemployed, you are the one that basically probably doesn't go around or is being impacted less in the going around, but maybe it's being impacted more in your routine in going out and coming back.
How are you measuring unemployment?
It's been measured by the census. Basically, each of local authorities give you a distribution of employment for that, and depending by age, and then we are giving them. So we are not
By neighborhood?
by the local authorities, what define the local authorities.
like community area here.
Yes, so like there is not. So we are just so all the information that we get is just like or a conditional probability or like a double cross.
You're just talking about the mobility synchronization of people in different neighborhoods ordered by the unemployment in the neighborhood.
Yes, yes, exactly. And then, of course, you can give a quantity. So the other thing is like, since unemployment is divided by categories, there are 8 categories in the census, and employment level 2. So for each categories, you have information about a quantile of the wage that they receive. So at this level, it's very, very good data, that level of employment in UK. And so basically, you can make an educated guess with conditional probability, of course, on how it's been impacted mobility synchronization and radius of generation for each of the different categories. And what we notice is that the lower managerial in the higher quantile are the ones that be more affected, probably. High wages are the one that basically is more affected in the space time, in the space. Finally, these are the cross check that basically validated some of our assumptions that I discussed to you in the first plot. Basically, what they ask us is like, what is the purpose of the trip? So basically, if you're going around, so you're wandering around, are you really wandering around because you're going just to strolling around, going to park or whatever, or you actually doing some activity? So in doing that, what we did, we did the first check about the duration of the trip, before COVID and after COVID, and we see that there is a shift in duration of the time. Basically, your trip is like, it's not 8 hours for working, but start to be a median about 5 hours, 4 hours, it's less. And then, of course, this can be studied by income level, and you see that there is a shift. And finally, what we check is that we want to check if they go out, so always keep in mind the privacy as much as possible. What we just check, we check the number of points we send to the provider. These are all the patches of Greenland that are in UK. Can you give us the number of pings that appear there? And you give us the number of pings, removing, of course, cemetery, area for cult, religion, beliefs, and hospital, leaving all this information. And what we notice, of course, is like more people are going to park during after the breakdown. And so basically, we are saying that that bump in the space that was reaching up faster than the time was just because people were trying to surviving and going around. Okay.
Can you comment on the higher managerial, so by buying the
So,
fact
okay,
that
yes.
moving less?
Actually, it's something that we discuss and we start to make some analysis. And then we feel in the paper has been just an educated guess written, by the way, is that basically there is we notice that in all the higher income, we can imagine that there is a power in bargaining, that you can stay more time at home. So there is the work home policy that basically were implemented during the third and after the second lockdown. That basically, if you can stay home, you stay home. Actually, in Europe, okay, either here, there's been still preserved 1 day a week, probably, that you can stay at home, but depends, of course, on the kind of works. And it's more, there's more percentage of people that this power in high income respect low income, because depending on the work that you do.
I was wondering if they could also get people to do things for them, like deliver food and things like
Yeah,
this that
maybe,
would otherwise
yes.
create a trip. So,
The idea is like, this could be an analysis that can try to understand this changing in particular income area, and then the consequence, either you can assess and change transit mode in some particular neighborhood that you know there are wealthy people, because why spend money in people that probably don't, because they have the power, okay, whatever. It's another problem for bigger stuff. And another thing that we might be interesting to consider is that if some of these analyses have been done during COVID, it might be help to impact the definition of shifts within different industries. Because basically, if you're able to say that, oh no, it's going to be very impossible. If you have a company A that works between the same shift of the company B, they work in the same area, if you have to do some policy for COVID, if you just change the shifts of 2 hours and say, okay, you still have 24 hours, but one is 8, the other start at 10, and whatever, maybe you have less people around, going around, and it was something that it would be impactful. So study either the time and the dynamics. Okay, then we have the last paper. Oh no, we have a data visualization, very fancy. Okay, you cannot see it because it's not too dark enough, but you can guess. So this is the radius of gyration. This data visualization that you see is going down, and F-ly, nobody's moving, and then coming back during the first step. What you can see when you see the data visualization of the time. So here you see, this is before COVID. So I know that there is a transform Fourier, this mathematical stuff they say that there is there, but if you squeeze your eye and you look at it, there is some synchronicity in the light. Moreover, it would be more clear if you see respect what happened during COVID. So it's very clear that during COVID is all over the place, and before COVID there is. So of course the maths is able to do their magic and they're able to give you numbers, but you can have a sense of this too. Okay, this has been published last year, already past 1 year, and visualization stuff are on our website. Last part is the last paper. This is very fast. It's working in progress, so it's not a big 5 minutes. So this idea is started to raise as much as possible the privacy. So we are not taking into consideration any user or anything. We'll see. And so the idea is like try to study how different POI interact with each other during COVID and after COVID. So this work is started with Robert that he got his PhD, then it's been finalized, hopefully, with Lavinia and Antonio. So you know that the interaction within, so people when they go to stroll, they go to do shopping, they go in particular area of the city, they go in one point of interest, they go in another one, they go to shop, etc. And please consider that we are talking about data from Italy, I will tell you, so like it's different behavior from US, but at least I think you can relate with how this works. Of course, POI are driven and they possibility to thrive, to gather more people by their spatial proximity. So if you are nearby other POI, they're very interesting, and then you thrive. And then diversity. Of course, there are areas that maybe, are all store that are shopping for clothes, or areas that are, but then there are more possibility for a block of POI to succeed if there is some diversity in the type of store. So the type of data that we have a 68 POI from all Italy, with 6 major cities, 52 million of stops. And then these are the data from Rome. This Piazza del Popolo, the Spanish Steps. Okay, this is really city center. Okay, so we have this data. We want to lose the privacy, and so no privacy. So no, sorry, as much of privacy as possible. So we just take in consideration the profile of the activity of a POI. Nothing else, okay? There's been another work recently, last a couple of months going on by Taka and Esteban. They did something not similar, but like alongside, but they are tracking each singular users and then checking how they move within POI. Here we are talking really high level, so we just have a profile of the POI. So we want to study this profile, and so we came up with a new way. There's not you, who's been around, but nobody have done this on the POI. And we use a visitation cluster detection technique. There is the self-organized map. It's a machine learning, you run it, you don't need to say there are 3 clusters for cluster. It's able to understand the number of clusters by its own, it's unsupervised. So basically he embedded he projected the pattern in space in 2D and tried to study the similarity with this 2D space, and then is able to create groups of this visitation. So we run this for all of the pre-COVID, all the point of interest of all Italy, and we came up with 4 visitation patterns. There is one thing that start to bring some interest to us. These are the 4 profiles that you can see. But then the first thing that happened is like, just check the type of POI that are there. Interesting, are all very diverse. So it's not that we are able to like, okay, these are clearly the shape of the stores that do 8, I don't know, open or in the afternoon for clothing, I don't know, whatever. Or these are the area about where these are the shape of the restaurants, or these are the shapes of pubs, or like these are just for eating and these are for entertaining. No, we have a very diverse clustering. But then you start to plot spatially. Yes.
I was wondering if you could talk about your selection of the POIs, because I just saw the quick.
No, okay, no, these are not the selection, sorry. These are just the top 10.
Okay, because I mean, they're all kind of very everyday.
So yeah, okay, yes. So all the POI that are there are all the POI. So we have 527 are all the POI defined by OpenStreetMap. So there is, so I'm just plotting, so I cannot put
Museums.
all of them
Yeah.
here.
So you also have museums or libraries?
Yeah, everything,
Oh,
everything, really everything. So all the APIs, I think there are more than 500 different categories, and we have all of them. Okay, so I just brought in the top 10 because like, and actually it's a bias because it's like, it's the city center with these are a lot of shops. There is like, okay, it was just to give you. Sorry, thank you for the question. So they are different, but then you plot spatially, and you start to see, okay, there is some aggregation of the blue, there is some aggregation of the red. Oh, something is going on there. So we start to have this question. Before trying to focusing on this question, we want to do the same run during COVID. And during COVID, we noticed that we have three shapes. Okay, we give some name, but just VLW. You don't care about these shapes. But then, okay, you can replot spatially again these three shapes, and then you can do the same stuff that we did before. So which one is which one? The W shape are really just less than 5%, and sometimes. Okay, this is not very nice, but then in data science or whatever, you can say there is noise. We don't care. And then, okay, forget the black one. Okay, it's like, I don't care. So the big difference is between V shape and L shape. Okay, that is the really chunk of the POI there. So we want to study these. We want to check the differences between the everyday activity and the everyday POI. But please go ahead, have a look. See. Either in some area, the purple one, there is some spatial aggregation, more or less. You can see this. So first thing, so we have a lot of features in the city. So we have the street division, we have the topology, the type of cluster, how many POI you have in 2 kilometers, how many POI you have in 500 meters. There is a lot of information that you can give. So there is machine learning for that. So you use just an XM boost to see which was the most important feature that is able to predict which one of these POI will be in the boost shape and L shape. We will give another name to this system. Boost shape are the one that survive because after the activity is still a lot. And the L shape is the one that are like, they're not doing so well. Okay. So we make as a proxy 1 and 0. So you die or you survive. Let's put it this way. And then you study this, and we put all the features, okay, that we can come. So weekly, day, pre-lockdown visitation pattern, etc., etc., etc. Then what we notice is that if we do the same analysis with only the contextual feature that only spatially related, what we notice is that density is very high. So the density of the POI is important. The category entropy, so how diverse are your POI within the area, is very important. And then the number of POI is very important. And actually, if you remove features from year to year, we're just losing the 2% of accuracy. It's not too much. So this means that the spatial one are the one very important. Okay, since we want to have a look about the spatial information that was clear, we started to create, since I'm in the Network Institute, the first network that I show you today, the network of POI. So it's basically the shortest path between each POI. Okay, you have a POI and then you check the shortest path. And this is the matrix for the city of Rome, okay, of the distances. Then we use an approach. I know, I'm Italian. So then we use an approach that's been developed by Elsa Patue, and is on 2017 on the hierarchy percolation. So basically what we did is just we created a percolation. So we cut our data set depending on the distance between POI. And what we noticed is that increasing the distance, so when we reach 200 meters, that is here, we are able to cluster the system in a very nice way. Okay? Okay. So basically, this is from Rome. We can do the same analysis for the 6 cities that we are studying. And what we notice, we have the interaction between POI that start to emerge actually at 200 meters is a workable, okay, let's call like the workable distance of Italian city do for like ancient mythological period. That we have within, so basically, all the POI within 200 meters are able to cluster within each other.
No, I'm sorry to interrupt. I
Yes.
just want to give you a heads up. We've got 5 minutes.
I got it. 2 slides. So then what we did, we started to study the possibility to have a cluster of slowdown depending on the entropy. So we study the distance. So we are able now to say that the distance is important. We have an idea about a threshold that is 200 meters. And then what we can do, we can study what happened in these 200 meters. So we have a highly diverse POI, and they make sense. And so there is more likely that they will survive. Because this means that we have basically the average cluster is the percentage of cluster that will survive respect to one. Finally, this is the last plot. That's hopefully, I hope this will be the last plot of the paper. I still don't know, but hopefully. So basically what we do, we study the likelihood to be in an isolated area. So since basically we created this system that created a hierarchical structure of our POI, what we notice that the POI that are in the leaf that are alone are the ones that are more likely to die. So they're gonna be in our L shape. And so we study this. And it's very evident that basically if you live in one leaf that is gonna be isolated, it's more likely that you are in the cluster that you're gonna die. Close, yes, sorry, close or survive, die.
Is that based on people who visit, or is it based on actual business?
No, people who visit.
Okay,
So we
you
didn't
could survive, but
It's not survive. It's like thriving of a visitation activity.
right. But if you're a restaurant and you pivot entirely to takeout, so it's like no one's
Yeah.
coming in, so it's okay.
Yeah, of course. Then yes, we should. It's very difficult to check this in Italy or whatever, but like yes, you're right. And that's. Thank you so much for your attention. I did. 1 hour. Hello, hi, yes.
Hi. My name's Nidra and
Nice to meet you.
nice meeting you. Thanks for the presentation. And I had a couple of questions. We work in 4 neighborhoods a little south west of here, Chatham, Avalon Park, Auburn Gresham, Beta Grand Crossing, and we too have looked at cell phone data and
Yes.
mobility. Not quite like you, but and so a couple of things. So one is that we noticed in looking at where our residents move through the neighborhood that are low income, this whole kind of 15-minute walkable city.
Yeah.
Our low income residents are doing the whole walkable 15-minute
Yeah.
cities because they don't have cars there. And so, which is very different from our higher income homeowners who get in their cars and go all over. And so I was curious in Milan that you didn't track the homeowners, and I wanted to know if the homeowners' spatial mobility was similar to the renters, or you just don't know?
I have no idea.
Oh, no idea. Okay.
I'm sorry, but actually it's a very interesting question, I would say. I can tell you that Milan, at least if you live within the yellow area, is really workable. So there is a very good transit service. And the big problems are like in the upper level and the boundary, as Luis outlined. But inside really is very tiny city.
Okay.
It's like Paris. It's like.
So it's more like a hub and spoke transportation system
Yeah,
in the center city?
Yeah.
Okay. That makes
and then there is trams that go around
Mhm.
the city.
And then I also wondered about the spatial,
One second.
okay.
So in that term, in terms of mobility, so there was the index, there was the velocity score, is how fast you are able to reach the different area of the city.
Got it.
And you see, so this is the only tentative that you can say. And car ownership in Italy is very high. It's very, very high. But I think that in Europe, we use the car in different way. that respect here sometimes, because but depends a lot. So there is a lot of study that I have knowledge about, and so. But I can tell you that in Rome, in Italy, car ownership is very high.
The other question is that when you looked at the cell phone data in our neighborhood, per the census in 2020, we had 117,000 people who lived there. But we had 50,000 more cell phones, so like 167,000
Okay.
cell phones are there at night. And so I was wondering, did you see any big disparities like that between the population and cell phones?
So usually, depending on the provider that you have, I don't know which kind of data you have. So it's possible that you have more phone than people, because in many countries people have 2 numbers. I have 3, so three numbers from 3 different countries. So it doesn't count, but it's possible. But for my access to the data, I always less, because basically you rely to one provider. There are multiple number of providers, and then there are possibility to do basically expansion factor or correction on basically the people that you have data on respect to the census, and are able to basically with that and the transit matrix, origin and destination, basically you're doing like correlation and distribution. And then basically you give, okay, this number of people represent 20 instead of 10 or 5. And then basically you correct, you under or overestimation. And there are, yes, the 2 ways to do is like or residential census, and the best one do residential and origin destination matrix. Because with these 2, you're able to basically have a very good correction. And then if you rerun your analysis after the correction, usually you have a very like 80% accuracy with, of course, outliers. That is very good because it's able to detect, okay, in this outlier, we are not very good. And then you can state that, okay, there is some problem in the data. Okay. We cannot have perfect one.
Thank you. One question online
Oh,
from one of our
yes.
fellows. Ariana, do you want to ask it really quickly?
Hello, Ariane.
Oh, yes. Hi, Ricardo. I'm so sorry to have missed you in person. I hope we get to connect soon. So I had a couple of questions. I'm going to make it brief because I know we're running out of time. But the first one is that sort of, I mean, naturally changes in mobility, right? Measured through the rate of gyration or synchronicity might be important for the structure of city if they are permanent. And so I'm curious if you can comment or whether you've explored the permanence of these effects after the pandemic. That would be sort of question number 1. And then the second one was, and perhaps I missed this, but I was wondering whether you've also looked at the role of synchronicity or the lack of synchronicity for experience segregation. So for example, I'd be curious to know whether like mobility is asynchronous within income groups. So for example, are people from similar incomes moving at the same time, but different from pre-pandemic normal, or whether people are just moving with similar incomes, moving all at different times, right? And this has obviously different repercussions for how we think about experience segregation. So just curious to hear your thoughts on that.
Okay, so for the experience segregation, unfortunately, no. I cannot comment on that because we didn't check that one.
Perhaps that's for future work. It would be interesting.
Yeah, actually, yes. I know. Yes, I'm lagging in answering because I'm thinking if it's possible, and it would be very interesting to do. Thank you for the question. And sorry, the first one was
just looking at the permanent changes.
Yes,
So how much?
Yes, sorry. Because okay, I was too much focused in the second part because I was tempted to do it. I'm tempted to do it, and the first part, yes, actually, what we noticed was just about the third lockdown. That was the last one. We did a final analysis that we didn't publish, and it was like not because we didn't have access to a very good data. But what we noticed is that there was a permanent change. Okay, not quote me, but basically in some data there was a permanent change in high income level about space-time dynamics. And but this was the only one that we assessed basically, because we ran the data again for like the last 3 months after the last lockdown, and we noticed this, especially in a part of London in the center. But then, of course, we didn't publish that because the data was not very good, and then it's just feeling about one plot I'm commenting. So just,
Yeah, I
But
mean, and it
those-
probably makes sense because it's probably the income group that is, you know, that is currently working from home or working remotely the most. So you would expect to sort of still see these differences permanently, I guess. Anyway, thank you. I'll reach out afterwards.
thank you so much. Hi,
You again. Thank you so much.
thank you. Sorry.